You've learned a little about catalysts, things that speed up chemical reactions, enzymes, the name of protein catalysts, so proteins that speed up chemical reactions in living things. We also use them in things like laundry detergent. So here's a graph of enzyme activity against pH. So this is a made-up graph. Real graphs, you could put real numbers on them for activity, but basically, if it's at the bottom, the enzyme isn't speeding up the reaction at all. If it's at the top, the enzyme is speeding up the reaction quite a bit. Remember the pH scale. Low numbers represent bigger numbers, so there's more acid. High numbers represent smaller concentrations of acid, so it's a base. Enzymes have ranges in which they work, and in a certain range they work the best. That is their optimal pH. For this orange enzyme, the optimal pH is close to 5. For this blue one, optimal is close to 10. The closer you get to 5 from either direction, the faster the enzyme will work. For this orange one, the closer you get to 10 from either direction, the faster it will work. The further you go away from 10, the slower it will work. Nothing more complicated than that. We're just reading these simple graphs. Higher point means working faster, lower point means working slower. Moving towards the higher point means you're increasing the speed. With temperature, temperature increases all chemical reactions. It increases the rate of all chemical reactions, but sometimes there's a point where the catalyst breaks down. So, in these lower temperatures, 25, 35, 45 degrees Celsius, our enzymes are going to work faster just because the chemistry works faster. But when we get up to high temperatures, 85 degrees Celsius, 90 degrees Celsius, the enzymes become non-functional. They denature, they unfold. And so they don't catalyze the reaction at all because the protein's broken. So when you're at low temperatures, if you get faster, the enzyme works faster. You get lower temperature, the enzyme works slower. But then if you jump in temperature a lot, up into higher temperatures, 80, 90 degrees Celsius, the enzyme's usually going to fall apart and stop acting as a catalyst. So that's all the information you'd need to answer qualitative questions about how pH and temperature affect enzyme activity.